Good day! So in this video, we'll take a look at some examples naman ng problems where we will use the second part of the fundamental theorem of the calculus. So ano ulit yung sinasabi niya? If we want to evaluate the definite integral from a to b of our function f of x, instead of doing the Riemann sum, we will just find one antiderivative out of an infinite possibilities. We'll just use one antiderivative of lowercase f of x na tatawagin natin, for example, capital F of x. So, gagamitin natin si capital F of x to evaluate yung dalawang limits of integration and take their difference. So instead of taking the Riemann sum, we'll just find an antiderivative, evaluate at b, evaluate at a, and take the difference. So ito siya. Okay, let's proceed. Our first example might be familiar. This is the definite integral from -2 to 0 of x squared plus x. I used this as an example in one of our sync session discussions na dinemonstrate ko kung paano siya kunin using the Riemann sum at ginamit natin yung leftmost point, then ginamit natin yung rightmost point, at medyo madugo yung solution na inabot natin. Let's see how this works, no, if we just use the second part of the fundamental theorem of the calculus. So first, let's evaluate the antiderivative. Tinanggal ko muna yung limits of integration. So the antiderivative of x cubed plus x, this is equal to x to the fourth over 4 plus x squared over 2 plus our constant of integration. That constant kasi can be anything, diba? So let's just choose a particular antiderivative and iset natin yung c to be 0. So capital F of x na gagamitin natin ay x to the fourth over 4 plus x squared over 2. 0 na yung c. Now, pwede naman kahit anong antiderivative. So if you want, may plus 7 dyan. Okay lang din. That will also work. Kasi notice, di ba, magsusubtract lang tayo. E di yung plus 7 sa first evaluation, mawawala dun sa minus 7 dun sa f of a, dun sa second na pag-evaluate natin ng function. Usually, we just use yung antiderivative where the constant is 0. And then, the definite integral from -2 to 0 of our function, this is, or isusulat natin siya as yung x to the fourth over 4 plus x squared over 2. Itong symbol na to, na may vertical line or vertical line segment, may limits of integration dun sa right side niya, -2 to 0. Ang ibig sabihin nito ay i-evaluate natin yung expression sa kaliwa niya from 0 tapos minus pag in-evaluate naman natin at the lower limit at -2. So this will be 0 to the fourth power over 4 plus 0 squared over 2, yung sinubstitute natin yung 0 sa x, minus pag sinubstitute natin yung -2 sa x. So -2 raised to 4 over 4 plus -2 squared over 2. So this is equal to 0 minus 4 plus 2, which will give us -6. Which, if you will recall, from our solution nung nag-limit tayo ng Riemann sum, -6 din yung nakuha nating sagot. And I hope you could appreciate kung paano siya kamas madali in terms of computational complexity. Kailangan lang alam natin paano kunin yung antiderivative nung function, yung x cubed plus x. And computationally, mas madali na siya. So, parang nililipat natin yung difficulty na instead of evaluating summations, maggagamit pa tayo ng various summation formulas, tas i-add natin sila, kukunin natin yung limits. Yung difficulty niya, inangat natin dun sa ability natin kumuha ng antiderivative. At hindi na dun sa ability natin mag-keep track of all the terms na lalabas when we evaluate the limit of the Riemann sum. Let's take a look at our next example. Okay, next example, we want to find the definite integral from 1 to 4 of square root of 2 plus x. So we've looked at similar problems na ng antiderivative ng may radical. So ang gagawin natin, express natin siya as a fractional exponent and we distribute it. So we'll write this as a definite integral from 1 to 4 of 2 times x raised to 1/2 plus x raised to 3/2. Then we apply the power rule. This will be 2 times x raised to 3/2 over 3/2 plus x raised to 5/2 over 5/2. So this is an antiderivative of our function na ini-integrate. Then we'll evaluate this dun sa limits of integration natin from 1 to 4. And then at this point, it's just a matter of making sure na tama yung computations natin. Sinulat ko pala muna siya using a more proper fraction na coefficient. So, imbis na 3 halves yung denominator, 3 na lang. So, just show how we evaluated this. I'll just do this na step by step. Of course, when you're doing this and you could, make it shorter kung paano siya ina-evaluate, lalo na kung obvious, okay lang yun. But I have to show, no, na sinubstitute ko yung 4 sa x minus pag sinubstitute ko yung 1 sa x. From here, we'll get that this is equal to 32 over 3 plus 64 over 5 minus 4 thirds plus 2 fifths. So, just do the sums and we'll get 326 over 15. So, may part lang siguro na maging tedious in terms of adding fractions. Pero, arithmetic na lang siya, di ba? We'll proceed with the third example. We want to find the definite integral from negative 3 to 4 of the absolute value of x plus 2. Now, before, ang gagawin natin sa kanya ay ipa-plot natin siya and we'll evaluate it in terms of area. This would be probably gagamit tayo ng area of triangles. But now, since we already know how to apply the fundamental theorems of calculus, we could just, rewrite this. Yung absolute value natin as a piecewise function. That this is equal to negative x minus 2 if x is less than or equal sa negative 2. Yun yung vertex, di ba? Kasi pag negative 2 yung x, 0 yung sa absolute value. And if x is greater than negative 2, then this is x plus 2. Then we'll rewrite our integral as the sum of the definite integrals from negative 3 to negative 2 of negative x minus 2 plus the definite integral from negative 2 to 4 of x plus 2. So, an antiderivative of negative x minus 2 is negative x squared over 2 minus 2x. We'll evaluate it from negative 3 to negative 2. The antiderivative of x plus 2, or one antiderivative of x plus 2 is x squared over 2 plus 2x, which we'll evaluate from negative 2 to 4 naman. And from here, it's just a matter of substituting, evaluating at the limits, tapos making sure that the arithmetic is correct. I'll just have to write them down, all the steps that I did. And evaluating the sums and differences. Just wait for the final answer. This will be 1/2 plus 18 or 37 over 2. And let's highlight that. It's our final answer. Okay, so maybe a couple more problems na may trig naman involve. Number 4, we want to find the definite integral from 0 to pi of sine x. So, before we apply yung anti-differentiation, ano ba tong region na to? Gusto ko lang siyang i-plot. So, let's plot it. This is the graph of sine x. So, from 0 to pi, that will be the region above the x-axis. So, again, it's a region na bounded by the x-axis. I would say from 0 to pi, pero 0 naman dun eh. So, it's just the x-axis and the curve. And smooth yung curve. And maybe you'd think, diba, na yung area niya, baka it's a factor of pi or it's irrational. But let's evaluate. So, ano ba ang isang antiderivative ng sine x? It would be negative cosine x. Let's just evaluate negative cosine x from 0 to pi. So, this is the negative of cosine pi minus negative of cosine 0. So, cosine pi is negative 1 and negative nun is positive 1. And cosine 0 is positive 1. So, minus negative 1. So, plus 1. So, 1 plus 1 lang siya. So, 2 yung ating definite integral. So, interesting, no? Na yung area ng region na yan, na may curve sa taas, tas flat sa baba. It's a nice integer. It's just 2. And one more example, we want to find the definite integral from pi over 4 papuntang pi over 2 ni 3 cosecant squared x. So we know that we could take out yung 3 sa definite integral. So we'll just take a look at the definite integral from pi over 4 to pi over 2 ni cosecant squared x. And we know that an antiderivative of cosecant squared x is negative cotangent x. So we'll just evaluate our antiderivative 3 times negative cotangent x from pi over 4 to pi over 2. So this will be equal to negative 3. Nilabas ko yung negative sa cotangent para cotangent of pi over 2 minus cotangent of pi over 4. Now, ano ba ang cotangent ng pi over 2? This will be cosine pi over 2 over sine pi over 2. So 0 over 1. And ang cotangent ng pi over 4, this will be cosine pi over 4 over sine pi over 4, which is both parehong square root of 2 over 2. So this will be negative 3 times 0 minus 1, which is just equal to 3. So the definite integral of our function, 3 times cosecant squared x, from negative pi over 4 to pi over 2, it's another nice integer. It's equal to 3. So what I want us to take away from this discussion is kung paano pinapasimplify ni second fundamental theorem of the calculus, or the second part of the fundamental theorem of the calculus. Yung pag-evaluate ng definite integral. It saves us the trouble of evaluating the limit of the Riemann sum. Na ang kailangan mo lang alam is mahanap yung antiderivative nung function na ini-integrate natin. So I hope na-enjoy nyo yung discussion na yun at salamat sa pakikinig.